Hello guys, welcome once again. Today we shall be talking about the capacitors found within the laptop motherboard. We have several types of capacitors. We shall be mentioning them. We shall be discussing them one by one. And before we continue, I'd like to wish you Merry Christmas. I believe we are in the season of feasting. We are at a Christmas period and happy end year. Okay. Anyway, today we shall be talking about the capacitors. First of all, we need to understand what are the types of capacitors which are found within the laptop motherboard. We have like three types. First, we have what's called chemical capacitor. Chemical capacitor, or sometimes it's called electrolytic capacitor, is a capacitor which contains chemical. As you can see, this one, this component here, I don't know whether you can see it. It's like a water tank. So this is what's called the chemical capacitor. Sometimes it is referred to as electrolytic capacitor. As you can see, that's the polarity. This side, which is not colored, is the positive side, and the other side is the negative for the ground. Apart from the electrolytic capacitor, we have what's called the tantalum capacitor. Tantalum capacitor is this one, this black component here. And in fact, sometimes it is labeled. You will find that within the motherboard, you find that component is labeled. Yes, you have several of them. You have another one here. This is a tantalum capacitor. You have some of them which are found, which are located around the processor. These black ones here. They also have polarities. They have, we can say they are polarized. That's the positive side and the negative side of it. Yeah, they are called tantalum capacitors. Apart from the tantalum capacitor, we have the common capacitors. This one. This one are called ceramic capacitor. In fact, sometimes you will hear them being referred to as MLCCs. This is multi-layer ceramic capacitors. There are several of them, and they are also vulnerable to the short circuits. Yes, the reason because most of them are located uh, across the main power lines. So whenever you have a power surge, those components can get shorted, and it can cause short in the motherboard. So as we continue, I'll be discussing how to test them, whether they are faulty or not, when they are shorted or when they are not. First of all, you need to have your digital multimeter. So this is my meter, it's off. Yes, you can see the pointer is pointing at the off, so meaning my meter is off. You need to turn on your meter and ensure that it points at the continuity. Yes, this calibration here, as you can see, there's a diode, uh, simple. This is called diode mode. Again, you can see there's an icon here for the bell. That's why it's called peeping mode. Yes, because when you put your when you put your when you turn your meter and the pointer points at this, it peeps, show the continuity. That's why this calibration still is called continuity mode. Yes. So to continue, make sure your meter is at continuity mode or diode mode or peeping mode. Then you need to ensure you have the baseline. So that's why whenever you put your meter into continuity mode, we normally put the probes against each other this way. As you can see, the reading is 0.0. So it means whenever I have a reading which has a resistance of 0.0 or nearest to the 0.00, it means those points are connected together in one way or the other. Again, as you can see, when I place them against each other, I can hear the peeping. Yes, that peeping, that's why it's called peeping mode. It shows the continuity of something. So capacitors, we said they have polarities. However, ceramic capacitor doesn't have the polarity when it is out of the motherboard. But the moment you solder them into the motherboard, it will have a point where it connects the positive line. That will be a positive side of that ceramic capacitor. So to test whether capacitors are faulty or not, let's start with the chemical capacitor. The chemical capacitors are this one. We said one side is the positive, another side is the negative. When you put the probes against the positive and the negative side of the capacitor, it should not beep. Or in short, it should not show any sign of continuity. For example, this one, as you can see, I have my red probe at the positive side and the black one at the negative side. You can see. Yes, I have some resistance. As you can see, it's 1 point something. It's infinite resistance. That's why you can see we have OL resistance. It means that capacitor is good. Even if you interchange the probes, however, we will have some readings, but there is no peeping, so it means that you can see. So sorry, yes, you can see. Yes, I have like 472 ohms resistance, so it means that capacitor is good. Again, let me show you a difference between that capacitor and this one. I have also another capacitor here. Let me show you. Yes, this capacitor here, you can see I have my black probe towards the positive line, towards the positive, and the red one in the negative. You can see what is the difference. Though it peaks, but you can see I have a reading like 5.1 ohm resistance. You can see actually that capacitor is still good. Why this one is good and the other one is good, but this one peaks? The reason you can hear some peeping here because this is the capacitor for the graphics. You can see there are some resistance from the graphics. So it means that capacitor is very good. You need to see the readings of 0.00 or almost 0. But this one, I have 5.1. It means I have the resistance from the graphics card. If I interchange the probes, still we will have we'll hear the peepings, but also we have what? The resistance. So whenever you put the probes against the component which should not peep and it peeps, so long as you see the readings, it means those readings is from the main chipset which is served by those components, especially the GPU, the CPU, and the sound bridge. Yes, whenever you have those main chipsets, it has the resistance in them. That's why it behaves like it is shorted. However, they are not. So that's how to test the chemical capacitor. Let's have a look at the tantalum capacitor. Tantalum capacitor is the same. So all the capacitors they have the same testing behavior. For example, this one we have this tantalum capacitor. As you can see, this is 5.1. So it means this one can either be the capacitor for the GPU or the sound bridge or the processor. However, the processor here it will have a different. This is its own capacitor. But this one, as you can see from the other side of this capacitor, sorry for that, from this other side, you can see I had a chemical capacitor which behave exactly like that. And behind here, you have also that tantalum capacitor. Meaning what? That capacitors are for the graphics. This is the GPU. Within this headset here, it's the GPU. I'll have the same readings from the processor. However, here, this I don't have any processor inside. So meaning the readings are okay is the actual reading for the capacitors. Let's have a let's test it. So here, let's start with this. So these are the tantalum capacitors. When I put the probes against each capacitor, you can see there are some readings. Yes, why is it not peeping? Because I don't have processor installed, right? Yes, here is another tantalum capacitor. However, this is of different. I don't know whether you can. Let me put it here so that you can see this one. So let me believe you. Let me just bring it. Sorry for that, guys. You will excuse me with my camera. It's swinging up and down. I don't know why. Yes. So this is what's called what? This what's called tantalum capacitor still. It will have the same behavior as any other capacitor, as you can see. Yes, there are some resistance and there's no peeping. Same case with this one, no peeping resistance. This one, no peeping resistance. If you exchange the probes, you have the same thing, no peepings, but still. So it means that capacitor is very good. Whenever I have a capacitor and I put the probes against each other, and you can hear the continuity beeping, the resistance is too low, it means that capacitor is shorted. The positive side of the capacitor is connected to the negative side, the negative to the positive, and should not be that way. You should have a different, uh, the line of positive and the line of negative are not connected, right? Yes, I'll describe for you. I'll draw. Let me just have a draw the structure of a capacitor. I don't know whether I have any pen around here. Just give me a minute. Yes, I find a pen. I don't know whether you will see my drawings. It's pathetic, right? Yes, sorry for that, guys. So we'll have this white paper. Let me draw for you how the multi-layer capacitor is. So a capacitor, it is in this format. You have the one side of the capacitor, and then you have another side of the capacitor. So these two sides of this capacitor, so let's assume that's a capacitor. Um, you'll excuse me with my pen. I don't know whether it's visible enough. Let me just try to put it thicker so that you might be able to see it. So this is what's called multi-layer capacitor. The multi-layer capacitor, it has 2 points or two sides. It is two-sided. Yes, this side of the capacitor and the other side. It is not soldered into the motherboard yet. So when it is outside this way, you cannot tell where is the positive, where is the negative. But depending on which side you will solder it onto your motherboard, it will determine the positive side and the negative side. So these capacitors, it tests the plates from this side. It has two plates running from this side. So these plates goes this way, but it doesn't reach the other point. And you have another plate from this side, somewhere there. It doesn't reach the other point. You have two from this side and two from this side, which are not connected to each other. So here again, you have another plate coming that way, and here you have another plate coming this way. So these plates come from this side to somewhere, from this side somewhere. So in between the plates, you have the space. So this space is which enables the capacitor to store some charges. It enables the capacitor to filter up excess power. It enables the capacitor to do what again? To allow the steady flow of power from one side. So let's assume you have the motherboard. So this is the main power line of the motherboard. So maybe the main power line runs that way. So that's the main power line. You can see this side is all that to this point. So this is the main power line of the motherboard. Let me trust your understanding what I am drawing. So this is, let's call it power line. Power lane, power line, power rail. We say this the same thing. Then this other side, let's assume this other side is the ground of the motherboard. So this other side is the ground of the motherboard. As you can see, this side of this plate, this side of this capacitor, it does the plates which come this way, and it doesn't reach the other side. You have the plates which come this way, it doesn't reach the other side. The main power line still, it has some plates, the positive plates. Yes, these are the positive plates, these are the negative plates. Yes. If you put the capacitor the other way around, still you will get the same results. So whenever this capacitor stores charges, sometimes if there are excess voltage flowing through here, and you have excess current flowing. So let's assume you have current flowing through this line, going towards going along the main power line. Let's call it that way. In case this capacitor stores a lot of charges within, so you will find that these plates will start expanding. Yes, it will expand if it is in excess until it crashes, it collapses. When it collapses, the two plates connect to each other. When the two plates connect, that's why we have a short or the leaking voltage towards the ground, and that's when you can get the short. So when you put the probes against each side of the capacitor, when the capacitor is good, you will not hear any beeping. In short, you will not have any continuity from this point to the other point. But when the plates collapse, if the plates collapse, you can see, yes, so meaning the two sides join. So when you put the props against the capacitor, you will be at the continuity. Yes, because I decided to do some writings, let me just finish showing the symbols. So we have the symbols for these capacitors. So what are the symbols for the capacitors? I'm sorry for my pen, actually it's not visible enough. You try to strain. As a man, you need to strain. So first we discussed about the chemical capacitor. The symbol for the chemical capacitor, it is this way. You will have this way, and it is having a curved whatever. You'll see there's no connection. So this one is the positive side, and here is the negative side. So this is what's called chemical capacitor. This is chemical capacitor. Apart from the chemical capacitor, you have the tantalum capacitor. Tantalum capacitor have the same symbol like this one. However, it doesn't have the positive and negative. It is not indicated. Yes, it is not indicated. So this is what's called what? Tantalum capacitor. This is tantalum capacitor. Then finally, we have what's called ceramic capacitor. Ceramic capacitor, um, it is this way. You have a line that way. You have a line that way. A line that way. This line is not curved because you don't have the positive side, and so this is what's called MLCC, multi-layer ceramic capacitor. Yes, this is MLCC. Yes, you can see this one. It doesn't have any positive or negative side. Yes, let me trust you. It was visible enough. So these symbols, you find them in the schematic. Whenever you're interpreting the schematics, these are some of the symbols you might find. So if you find this symbol, it will tell you that is a chemical capacitor. If it is this way, that's a tantalum capacitor. And if it is this way, that's a ceramic capacitor. Yes, and I say the chemical capacitor is also called what? Electrolytic capacitor. So let me hope you will not forget. So that's electrolytic capacitor. So let's proceed with our measurements. Yes. So far we've tested the chemical capacitor, tantalum capacitor. Then next we shall be testing the MLCC. MLCC the same process. So my meter is almost closing up. So let me just refresh it. Yes. Continuity mode. The reading still the same. Yes. Let's have a look at the ceramic capacitor. Ceramic capacitor behave exactly the same as chemical and tantalum capacitors. For example, this one. We have some ceramic capacitors here. So this is ceramic capacitor. Let me just bring it closer to you. So this is my meter. Yes, let me just hold it this way. Yes, here I have the ceramic capacitor. So these are some of the ceramic capacitors. These ones, these two of them. When I put the probes against, you can see there's some readings in my meter. So it means what? It means that capacitor is very good. Let's have a look at this one. These ceramic capacitors within the CPU socket. Because I don't have the CPU installed, so I'll get the normal readings for that. So that one might be a problem. You can see. Yes. Again, thanks for having that reading. I will have forgotten that. When you have a readings which behaves that way, for example, that you can hear that. Yes. In case I have a capacitor behaving that way away from the main chipset, it means that capacitor is partially faulted. Yes, that capacitor is partially faulty. You need to replace it. It might not mean that exact capacitor. Maybe a certain capacitor along that lane where that capacitor is soldered have a problem, but that problem is partial. So that's why you might hear some breakage of the continuity. So let's test these capacitors within the main chipset, that is the GPU. We will have some readings, however, we will hear the beeping. You can see I have resistance of 5.1 with the capacitors which are located just behind the GPU. Yes. Here we have the GPU. Yes, within here I have the GPU. There's a GPU chipset. These capacitors around here serve that GPU, as you can see. So as you can see, this capacitor here. Sorry for that. Yes, that one doesn't pip. Yes, if it doesn't pip, it means that's a different capacitor. I can tell you for sure this capacitor is not for the GPU. Why? Because I know you will not see it, but let me just explain to you. Between these components and here, I have a border. There's a boundary between the two. There's a border here. So it means these components are for other work. So it connects somewhere else, right? Yes. And sometimes you might test the capacitor differently. You put your black probe to the ground of the motherboard. I put my black probe. Let me use this one because I haven't tested this capacitors here. Yes, we shall be testing this one. I put my black probe to the ground this way. This is my ground. So once I placed my probe to the ground, I'll have my other probe towards one side of the capacitor. Because I know one side of the capacitor is connected to the ground and another side is connected to the power line, I expect to see some readings the other side, and the other side I expect to see zero resistance, or I expect to hear the peeping. So let's have a look at these ones. This side, you can see I have readings. Yes, I have infinite resistance. But this other side, I expect to hear the peeping. You see? Yes, and I need to see zero resistance. So it means this side is connected to the ground, the other side is positive. What about this one? This one still good? Good. Yes. Let's revisit this one. What about this tantalum capacitor within the gypsum? This other side, is there zero? Why? Because this side is the ground. This side, I expect it to peep, but there's some resistance. You can see? Yes. So meaning the capacitors within the chipset, the main chipset, it will peep from the positive side, but there's some readings. But the negative side, it will have a zero resistance and also peeps. So guys, thank you so much. Let me trust at least I have helped you somewhere. Yes, I am very happy because you've been patient with me throughout this discussion. And let me trust you're getting something because having the laptop repair skill or having any repair skill, it will help you a lot. You will be independent in your work. Yes, and it is very amazing. Actually, since I started doing the repair, I have never regretted it because it's a wonderful job. Yes, you will get to network with so many people. You will get to meet a lot of people in the field. Yes. So thank you so much, guys, and please subscribe to this channel, share with your friends. Yes. Again, guys, before I forget, we do laptop repair. In the case you know someone who has a problem with his or a laptop, please you can connect us with them so that we might be able to you might help them. And again, we do teach. In case you want to learn about the repair, please you're highly welcome. You can join us. My contacts are in the bio, so you can get my contacts there. You can call me, you can text me, so that we can yes, we can network. We say this it's about networking. Yes, in this field we will get to know each other. So thank you so much, guys. See you in the next video. Goodbye.